Hi everyone, I'm Anindita from Ontario Tech University and I'll be talking about my paper titled Energy Management Systems for EV Charging Stations, a Review. Generally, EMS charging stations are used to optimize the power flows between the different resources present in the system, and more specifically for EV charging stations, they also include the incorporation of V2G mode of operation. To give an overview, there are different categories of energy management systems, such as building energy management systems, microgrid energy management systems, EV charging station energy management systems, and home energy management systems. This paper will focus on EV charging station energy management systems. In V2G modes of operation, the EV owners can provide different services to the grid, such as demand response, which include load shifting and peak shaving, ancillary services such as voltage regulation, frequency regulation, and spinning reserve. Then they can also sell back power to the grid for revenue. And finally, the EV batteries can act as a UPS system. In the V2V mode of operation, there are two different categories: direct charging and aggregator-based charging. In direct charging, you use algorithms based on matching theory and optimization to perform the EMS function. While in aggregator-based charging, you have the grid, which acts as an aggregator, receiving the power from the EVs and then distributing it to other EVs, as well as optimizing the power received from the other resources through the EMS. Now I'll be talking about the three different methods used to develop the energy management system for EV charging: optimization, machine learning, and game theory. In optimization, you optimize a set of variables by minimizing or maximizing a particular cost function or revenue function while satisfying a set of constraints. For EV charging, the variables to be optimized are the power flows. The cost function could include operational costs, revenues, customer satisfaction, and so on. And the set of constraints are the physical constraints of the system. Different machine learning models are used to predict the time of arrival of EVs or the low demand of EVs. The reason they're not used for optimizing the power flows is because of the lack of data to develop the models. Different models such as neural networks and LST models are used to perform these tasks. In neural networks, you have the input layer, which processes the input, passes it on to the hidden layers, which learns the relationship and predicts the output accordingly. In LSTM models, you have the time series input from which the relevant information is stored and then combined with the present input and then used to predict the output. In game theory, you have a set of players such as EV owners, charging station operators, and the utility play a game as defined by equations 3, 4, and 5. The goal of the game is to reach the Nash equilibrium as defined by equations 6, 7, 8, where the payoff functions where all the players are optimized. Thank you to IEEE IES for organizing this SYPA contest.